Hello, dear students. This is your Engineering Mathematics 3 lecture. In the first unit, linear differential equation with constant coefficients. In first unit, in last lecture, we discussed type 5 or case 5 of shortcut method. Shortcut method is used to find the remaining half solution of LD, linear differential equation with constant coefficients. Now here type 6 or case 6 of shortcut method. Shortcut method is used to find the particular integral. Now see what is type 6 or case 5. When the function is f of x is equal to x into v, where v is any function of x, then in that case how to find the pi? The formula to find the pi is 1 upon phi of d into f of x. Here f of x is x into v, product of two functions. One of them is linear function x and v is any function of x. Now the formula to find the pi when the function is x into v is here in bracket x minus phi dash of d upon phi of d, bracket complete, into 1 upon phi of d into v. Now there is that note is there. That first point is that here v is any function of x, mostly it is trigonometric function, and second is power of x must be 1 here, and then we can use this case 6 x into v. This is the formula of case 6 and the two remarks are there. Now the example of case 6 is here. Solve d square minus 2d plus 1 into y is equal to x into e raised to x into sin x. This is one example, first example. Here it is in reduced form phi of d into y is equal to f of x. So you equate that phi of d equal to 0, so that you will get the auxiliary equation, that is d square minus 2d plus 1 is equal to 0 is an auxiliary equation here. Now, what are the factors of d square minus 2d plus 1 is equal to 0? It is a perfect square, d plus 1 whole square is equal to 0. So the factors are here, d is equal to 1, 1. Means there is single factor 1 and it is repeating 2 times. So the complementary function is here, c1 plus c2x into e raised to x. Using the rule of complementary function, when two roots are equal, then how to write the complementary function? We are discussing in first lecture already that rules of complementary function. So here we can write when two factors are repeated and they are real numbers, then how to write the complementary function. So the complementary function is c1 plus c2x into e raised to x. Now how to find the pi? That formula is 1 upon phi of d into f of x. Here phi of d is d square minus 2d plus 1 into f of x. F of x is here x into e raised to x into sin x. There is product of three functions. One of them is exponential, second one is linear function, and third one is a trigonometric function. So if this is the case that there are three functions, then you solve for first exponential function and you consider the remaining term as a one function. So here exponential function is e raised to x, so you solve for exponential function and remaining term as one function. So it is the case now, case 5, e raised to x into v. Now you know how to solve for e raised to x into v. You replace the term of d by d plus a. Here the coefficient of exponential function is 1, so you replace the terms of d by d plus 1 e raised to x as it is in bracket 1 upon, replace the terms of d by d plus 1, so that we have the term d plus 1 whole square minus 2 into d plus 1 into the remaining term is here x into sin x, that x into sin x as it is. Now simplify, next step simplify the denominator term, d plus 1 whole square, its expansion is d square plus 2d plus 1 minus, now you solve for this bracket term d plus 1 into 2, so the term is minus 2d minus 2 plus 1 into x into sin x. Now simplify this denominator term again, so that you will get the term e raised to x as it is into 1 upon that 2d minus 2d get cancelled, 1 plus 1 2 minus 2 get cancelled, and the term is only 1 upon d square. So e raised to x into 1 upon d square into the function is here x into sin x. So write here x into sin x. So now you solve for x into sin x. X into sin x means it is now the case 6x into v case. Now solve for x into v. So the formula is here for x into v. See, the formula is here. Discuss it here. For x into v case, the formula is x minus phi dash of d upon phi of d bracket complete into 1 upon phi of d into v. So we are using this formula here because the case is x into v. X into v. E raised to x as it is because the work of x e raised to x means the exponential function is over here. So the exponential function as it is. Now solve for x into v. The formula is x minus phi dash of d. Phi dash of d means derivative of d square. Derivative of d square is 2d. So write in numerator 2d upon d square because phi dash of d upon phi of d. Phi of d is d square. So write in denominator d square. Bracket complete into 1 upon phi of d. Phi of d is d square. So write in denominator d square into the function v is sin x. So right here sin x. We are using case 6 here x into v. Now that exponential function again e raised to x as it is. Now solve for this outside term 1 upon d square into sin x. How we solve for sine function? It is the second case or type 2 of shortcut method. Sin x plus b case, trigonometric function case. In trigonometric function, we replace the terms of d square by minus a square. Here the value of a is 1. The coefficient of trigonometric function is 1. Its square, if we take the square, it is 1 again. And give negative sign to it. So replace the terms of d square by minus 1. We always replace the terms of d square in trigonometric function and not the terms of d. You remember it. And so replace this d square by minus 1. If we replace this d square by minus 1, then the simplification of this term is minus sin x. And so in next step, you take minus sign common. It is equal to minus e raised to x as it is. In bracket term x minus 2d upon d square into sin x. Now you solve this bracket term for sine function sin x. Again in next step minus e raised to x as it is. Now solve for sin x. Solve this bracket term for sin x. So x into sin x is x into sin x minus 2 as it is d by d square. D by d square means 1d will be get cancelled. So here the term will be 1 upon d. 1 upon d of sin x. 1 upon d means integration of sin x. When the term of d is in numerator, in that case we take the derivative. When the term of d is only single term of d is in denominator, then in that case we take the integration. So minus 2 as it is, d upon d square means simplification is 1 upon d. 1 upon d means integrate sin x. Integration of sin x is minus cos x. And so this minus sign will become plus. Minus plus 2 as it is, derivative of integration of sin x cos x minus cos x. So it is plus 2 cos x. So this is your answer here. Means the pi is this one. And so the general solution is y is equal to cf plus pi. And so y is equal to cf plus pi. Cf is here c1 plus c2x into e raised to x minus the pi is here minus e raised to x in bracket x sin x plus 2 cos x. So this is your answer for the example. Now next example, solve 1 minus d square into y is equal to x into sin 3x. It is again the reduced form of LD. Phi of d into y is equal to f of x. So the auxiliary equation is here 1 minus d square is equal to 0. It is an auxiliary equation. So the factors 1 minus d square is equal to 0 means 1 is equal to d square. Means the factors for d are plus 1 minus 1. These are the two factors. They both are real numbers and they are distinct, and distinct means different numbers. So the complementary function is here c1 e raised to x plus c2 e raised to minus x. Now how to find the pi? Pi is 1 upon 1 minus d square into x into sin 3x. sine 3x. Now solve this, find the value of pi when the function is in the form of x into v. Now this is a case 6, x into v is case 6. So using the formula, you will get the pi for x into sine 3x. So the formula is x minus phi dash of d. Phi dash of d, derivative of this pi of d. Pi of d is here 1 minus d square. Its derivative is d square derivative 2d, minus sign is there, so give minus sign, minus 2d upon your phi of d. Phi of d is 1 minus d square, so write 1 minus d square in bracket complete into 1 upon phi of d. Phi of d is here 1 minus d square into sine 3x, sine 3x. Now solve this term which is outside the bracket, 1 upon 1 minus d square into sine 3x. So replace, how to find the pi, how to solve this term of sine 3x. You use the case 2 result, case 2 formula, when there is trigonometric function, and in that case we replace the term of d square by minus a square. So here the value of a is 3, so its square is 9, so replace d square by minus 9, and so the term is here 1 minus minus of 9 means 1 plus 9 is 10 into sine 3x. Now this 1 upon 10 is constant term, so you write down that constant term outside the bracket. You solve this bracket term for sine function sine 3x. So x into sine 3x is x into sine 3x plus 2d upon 1 minus d square into sine 3x. Now solve this term for sine 3x. Now replace the terms of d square by minus 9 because we are solving for sine function. Again the same situation is here, that a is 3, so the square of 3 is 9. Give negative sign to it and replace the terms of d square by minus 9. So 1 minus of minus 9 means plus 10, and 2 upon 10 is 1 by 5. So the term is here 1 by 5, and d means derivative. If single d is there in numerator, then you take the derivative of that function. So derivative of function sine function is here cos functions, derivative of sine 3x is cos 3x into 3 because the coefficient of angle is 3x. So the composite derivative is here 3. So the complete term is 3 cos 3x upon 5, and this is the pi here. And then the general solution is here y is equal to cf plus pi, which is equal to c1 e raised to x plus c2 e raised to minus x plus 1 by 10 in bracket x sine 3x plus 1 by 5 in bracket 3 cos 3x. This is the general solution. And the next example, this is for your homework. You try to solve this example. D square plus 4 into y is equal to x into sine x. It is again the x into v case. You can use the formula of case 6 here, and this is case 6. Here all the methods, all the cases of shortcut methods are over here. In next lecture we are going to discuss the WebP method of variation of parameters is used to find the particular integral. This is the third method to find the particular integral. Thank you.